Hi everyone, my name is Archie and today I'm going to be talking about iterators. Before I get into iterators, I want to talk about something that everyone should be aware of already, which is the for each loop or enhanced loop. This is a handy slice of code that helps us to do a mundane task easily. Almost all high-level programming languages support it, but no matter what the language or what the syntax, the output is the same. The for each loop gives us the ability to iterate through a list or collection effortlessly, to either read and use the data stored in each location, or in some cases, actually modify the data at each spot. Although used often, there are many programmers that do not know how it works. The for each loop, in fact, works by using a very simple but much less known tool called an iterator. And that's what we're talking about here today. An iterator is any class that implements the iterator interface. Since I will be demonstrating the creation and use of an iterator today in Java, let's look in the Java API at the iterator interface. As you see here in Java, when implementing the iterator interface, there are only two methods that are required to be written. The hasNext method, that lets us the program know if there are any more items to look at. And the next method, which returns the next piece of data and moves on to the next item in the list. Used together, these two methods give you all the tools you need to move through the data structure one at a time, obtain the data at each stop, and finish when there is nothing left to obtain. The concept goes like this. The iterator starts at a location in the structure, generally the first location or the head. From here, the program uses the hasNext method to see if there is something else in the list to return. As long as there is, then the next method is called and the data is saved to a variable. The programmer can then use that variable for whatever he needs. Then the loop starts again on the next piece of data until the hasNext finally returns false, meaning there is nothing left to return, and the loop finishes. This is how the for each loop works. The magic of an iterator is that they are custom made to the data structure you are using. Because of this, it is generally common to nest the iterator class inside of the data structure class, since it will only be good for that particular data structure. In order to show you an example, I have written a data structure, a very simple data structure, a linked list, and we are now going to put an iterator into it. Now, if you look, I made an iterator tester. So basically this just, in this tester here, this makes a new linked list and adds a bunch of words into it. And then I try using a for loop. But you can see here that there's an error. If you hover over the error, you say, can only iterate over an array or an instance of Java lang iterable. What that means is the compiler is looking at my data structure and trying to see if there is an iterator there. Well, how does it know if there's an iterator there? Well, it turns out that if you're going to be putting an iterator into a class, you need to implement something called iterable. And what iterable means is that this class can produce an iterator for it. So let's just do that really quick. Okay, so now that we have that implementing iterable, now we still have an error. What's the problem? Well, the problem is that this interface has one method that it needs, and that is an iterator method. It's called iterator. And what that method does is return an iterator. So let's go ahead and add that method. Okay, so now we have no more errors, but it really isn't doing anything. The problem is we don't have our iterator set up. So let me go ahead and type, like we said before, there is usually generally a nested class inside that is an iterator. And let me go ahead and type that up, and then I'll go ahead and explain it. Now I'm going to go ahead and call this class iterator thingy. And honestly, it doesn't matter what I name it. The class name can be anything as long as it implements iterator, then this class is considered an iterator. So I will go ahead and put in some class level variables, and then we have to implement the methods that need to get implemented because of the iterator class. There we go. And I'll finish this up in just a second, and I will explain everything that I'm doing. Okay, so what I have done here is write a nested class inside of our data structure. Now, this nested class is an iterator, and it is an iterator because it implements the iterator interface. The iterator interface, as you recall, needed two methods to make it complete, the hasNext method and the next method. Well, in order to use these two methods, in order to make them work, I had to set up some class level variables. The two class level variables are a node reference pointer called current, which we are going to end up pointing to the very first thing in the data structure, and then an integer called count, which is going to keep track of how many items we have gone through. Now, in the beginning, we set the current reference to head because we're going to point it to the very first thing, and we set count equal to 1 because we're going to start on the first item. Now, how do we know if we have another item or not? Do we know if this hasNext needs to send back a true or false on whether or not there is more items in the list? Well, since count starts at 1 and gets incremented every time we go through a new item, it would make sense that as long as count is less than the size of our list, then we have more items to go through. When we're on the first spot and the count is 1, then if we have 10 items in the list, then that means we have 9 more items to go until we're at the end. So what we're doing is returning whether or not count is less than or equal to current size. So that's a pretty simple method. The next method is the next method, which takes the data at each location and returns it. And it also increments the pointer that we're at to the next location. So what I did was set up a temporary variable that grabs the data at each location, and then it takes that current pointer, which starts on the first one, and increases it to the next one. And then finally it increases count, which helps us determine whether or not we have more left. And finally it returns the temporary variable. And that is how an iterator class is set up. Now, up here, what the data structure needed when we implemented iterable, it needed something that returned an iterator for that data structure. So that is what we ended up doing right here. When this method gets called, it literally just returns an instance of this iterator thingy class, which is an iterator. I know I'm using the word iterator all over the place, and it can get confusing, but I hope this is all making sense. So after we save this, you will see that our iterator tester no longer has any errors. This list, that is the same list we had before, which is just a linked list, now is able to be used in a for loop because the compiler sees it as something that returns an iterator for it. So in order to test this out, we'll go ahead and run it. And what I did here is I added 6 words into the linked list and used the for each loop to print out each one of them in order. This is how an iterator works. Now, just to recap, for each loops use iterators in the background to do their heavy lifting. When adding an iterator to a data structure, the general idea is to add it as a nested class, since this iterator will only be used by this data structure. For a class to be an iterator, it needs to implement the iterator interface, which has the methods hasNext and next. For any data structure to be able to use syntax such as a for each loop that uses iterators, the data structure class must implement iterable, which requires it to have a method that returns an iterator. So that is how an iterator is written and used. Although the exact syntax and required methods differ from language to language, the overall basic concept is the same. Although you don't have to know how they work to be able to use them in things like for each loops, I hope that understanding a little more about iterators will help you out in the long run. Thanks.